Hi friends, today we are looking at solving a simple cubic equation. The equation is this: x to the power of 3 equals 64. As you know, a cubic equation has at most 3 solutions or roots. Just by looking at the equation, you can say x equal to 4 is one of the roots. There are 2 more roots. So we will use a method to find out all the 3 roots together, in which this will be one solution. Okay, for that, take 64 to the left side. You get x to the power of 3 minus 64 equal to 0. Now 64, as you know, is a cubic number. So you may write it as x to the power of 3 minus 4 to the power of 3 equals 0. Now we will use an algebraic identity, which is like this: a cubed minus b cubed equals a minus b multiplied by a squared plus ab plus b squared. Now in the given equation, x equals a and b equals 4. So expand it using the right side, where the first term is a minus b. In this case, it will be x minus 4. A minus b will be x minus 4. And the second term, a square, which is x squared, because a is equal to x. Then comes ab. A is x, b is 4. So x into 4, 4x. Plus b squared, which is 4 squared, equal to 0. So we factorize the cubic polynomial into a linear polynomial multiplied by a quadratic polynomial. Now this means what? Either the linear polynomial equal to 0 or a quadratic polynomial equal to 4 square, let me write as 16, equal to 0. Or there is another possibility of both being 0. It wouldn't give us anything more, same thing. Okay. Now this gives you the first solution which we had calculated in your mind. So this is solution number 1. By solving this quadratic equation, you get the other 2 roots. Now how do you solve this quadratic equation? As you know, there are different methods. I'll list out all the methods. At least 3 methods I will list out here for solving a quadratic equation. The first one is completing square. Second, factorization. Third one, using the direct formula. Let me use the first one, completing the square. In completing the square, what do? You write the first term that as it is, x square. Second term also we write as it is. After that, the coefficient of x is 4. You take the half of that, which is 2. Then square it. So 2 squared, which is 4. You just add 4 to this number. Okay. Then when you add 4, you should subtract also. Otherwise, value will change. Now there is plus 16 here. Okay. So we just added 4 and subtracted 4. This procedure works in all quadratic equations. Now the next step, these 3 terms will form a perfect square. That will be x plus 2 to the power of 2. This will be. Okay. And this will be minus 4 plus 16 plus 12 equal to 0. Now send 12 to the right side. You will have x plus 2 to the power of 2 equal to minus 12. Yeah. Here it is plus. On the right side it will be minus. Now take square root on both sides. On the left you have x plus 2. And the right side is, as you know, plus or minus square root of minus 12. Yeah, square root of minus 12, they are not real numbers, they are imaginary numbers. I'll give you the simplification of this number on the margin. Minus 12. We will simplify it here. See, this number we can write as square root of 4 multiplied by minus 3. This again, you can distribute the root side, square root of 4 multiplied by square root of minus 3. Square root of 4, as you know, is 2, and this we write as square root of 3i. Okay, the explanation is this. I is a number, I think you are familiar with that in the complex numbers. This 2 comes from here. I hope it's clear. Now let me substitute that here, plus or minus 2 root 3i. So x plus 2 equal to this. Send 2 to the right side, you will have this. 2 on the right, this becomes, see, I'm not writing this step. You can write again x plus 2 equal to this. So taking 2 to the right side, you will have minus 2, and then comes whatever there already on the right side, which is 2 root 3i. So these are the other two roots. One root is minus 2 plus 2 root 3i. The other root is minus 2 root 3i. X equal to 4 and these two roots. These are the solutions. Now if you want, I will verify these complex roots. It's a little long process. Let me take one of the roots from here and I will cube that number and you should get it as 64. How do you go about that? If you take x cubed, you will have minus 2. I am taking only the plus 1. 2 root 3i, the whole cubed, or the whole to the power of 3. This on simplification must turn out to be 64 for the solution to be correct. I'll write this term first. This is the positive term. So let me write it like this. 2 root 3i minus 2 the whole cubed. 2 is common. So let me take that outside. It will come out as like this. Root 3i minus 1 closed. Then the other bracket cubed. So that's equal to 2 cubed root 3i minus 1 the whole cubed. But this on further simplification, 8 root 3 cubed, that will be 3 root 3. This is the explanation. Root 3 cubed is what? That is root 3 multiplied by root 3 multiplied by root 3. What is that? 3 multiplied by root 3 is just 3. And then there is this. That's how I wrote this here. Then I cubed equal to I squared multiplied by I. I is defined to be square root of minus 1. Squaring both sides, you will have I square, root sign will go minus 1. Here I square will be minus 1 because I is equal to square root of minus 1. So I square. So instead of I square, I am writing minus 1 multiplied by I. And that's equal to just minus I. So I cubed will be minus I. And this minus 1. Then 3 root 3 I. Now minus 3 multiplied by root 3 square. Root 3 squared is just 3. Because this is root 3 multiplied by root 3, which is 3. Then I squared, I have shown here, minus 1. So this is what you get. Now this will be minus, you can write here, 3 root 3 I minus 1, 3 root 3 I. This is what? Minus multiplied by minus plus 3 multiplied by 3, 9. Now look at these two terms. One is plus, the other is minus. They will cancel out. And you will have 8 minus 1. This is gone. Plus 9. This is 8 times. This on simplification. 8. And you get 64. This shows the solution we had was correct. That's all.